When we want to use machine learning, we basically need to decide about three things. The first one is what task we want to solve. The second one is what kind of machine learning approach we want to apply. And the third one is the data we want to use, the set of examples that describe the task we want to solve. But when we follow the basic principles of machine learning, we can end up in a situation that the model is very good at solving the task. But actually, this is not always what we want to have. This is not always a desired behavior of the model. Why? I'm David, I'm a PhD student in computational linguistics, and in this video I'm going to explain the basic but very important principles of machine learning. I will split this topic into three parts. The first part will be about the general principle of machine learning. The second part will be about why sometimes happens that the model is too good and why this is not really what we want to have. And the third part will be about how to address this issue. So let's start with the first part, the general overview of how machine learning works. I'll show it in an example. So the first thing we need to decide is what task we're going to solve. So let's say that we have a classification problem. We have a set of images and we want to decide whether there is a dog or a cat inside the image. In order to do that, we need to have a set of examples where we have dogs and cats in images. And we need to decide what machine learning model we will use for that. We can view this machine learning model as a black box, which means that we don't really see how it works inside, but we can observe what it does from outside. And what it does is it expects the input, in our case it's an image, which contains either a dog or a cat, and it outputs a prediction, it outputs a classification, a label, whether this is a dog or a cat. And the principle of machine learning is basically that the model goes iteratively through all these examples of images and tries to learn the features which are inside the images. So it tries to learn the difference between a dog and a cat. In practice, it might, for example, mean that it learns the shape of the face or the shape of ears or eyes. We don't actually know what exactly the model learns because, as we said, we view the model as a black box. We don't really know what it exactly does, but we can observe that it learns something based on the output. So if the model predicts correctly, it's rewarded, and the model knows that some features it tried worked. So it can learn that this feature is probably useful, and it will try to decide based on this feature next time whether this is a dog or a cat. So we are getting to the second part of the video. As the model goes through the data, the model learns and learns and learns. We can go through the data not just once, we can go through the data several times, and we measure the performance, the quality of the predictions of the model. In this case, this is a binary classification. It means that it predicts two classes, two labels, whether there is a dog or a cat, and we evaluate this model whether the prediction is the same as the correct answer. In this situation, it can really happen that after going through this dataset, through the set of examples we have several times, for example, dozens of times or hundreds of times, it depends on how many examples we have, it can really happen that the model learns so many features that the model's prediction is 100% correct. So if we provide it with any feature from the data we use for training the model, it predicts correct answer. But there is the catch. What if we serve the model with some different image which it didn't see during this training? It can happen that the model doesn't predict the class of this image correctly. The reason is that we overtrained the model. The model learned too many features which are actually not really relevant in general scenario of predicting whether there is a dog or a cat. I will show you this in an example. So let's say that our data, which the model is trained on, which is called training data, let's say that all images which contain a dog are outside, let's say in a garden, and all images which contain cat are inside. The cat is sitting on a very cozy sofa in a living room. And it may happen that the model learns the environment. So it learns that if there is a garden, there is definitely a dog, because in every picture it saw a dog. And the same thing is for cats. It always saw cats in the living room, so it might think that this is a very important feature for predicting cats, and as soon as it sees a living room in the background, it decides that this is a cat. But it can happen in a real world scenario. Dogs are not only in gardens, they can be in living rooms as well. And cats can be seen also on streets, etc. And in this situation, the model's performance on unseen data is very, very bad. And this problem in machine learning, when the model is very good at solving the task during training and it's not so good at predicting the labels outside the training data, is called overfitting. So overfitting in machine learning occurs when a model learns the training data too well, including its noise and outliers, leading to poor performance on new unseen data. So how to address this issue? This is the third and last part of this video, where I'm going to explain what to do and how this is done in machine learning in general. So to prevent overfitting, basically we need to have more data than the training data, because we want to know how the model behaves on the data which it doesn't see during training. So for this, in machine learning we use a separate set of data. It's called validation data, and basically during the training of the model, on the training data, we evaluate the model at each step on the validation data. The validation data is different than the training data. The pictures in the validation data are different, but they are from the same domain. It means that if we are predicting whether there is a dog or a cat in the image, it means that the validation data also contain pictures like that, either dogs or cats, but there are different dogs or different cats. And when we train the model and we see that the model is very good at deciding whether there is a dog or a cat in the picture, and the picture is from the training data, but it fails to decide whether there is a dog or a cat on the validation data, we know that there is this overfitting happening. So this is the basic principle which is used for detecting overfitting, and there are also several methods how to prevent overfitting happening. This set of techniques is called regularization, and basically regularization is a set of methods for reducing overfitting in machine learning models. Typically, regularization trades a decrease in training accuracy for an increase in ability to generalize. Because ideally, we want to have models that are able to generalize. Generalization basically means that the model can perform well on the data that it didn't see during training. And this is the core goal for machine learning and for training machine learning models. So thank you much for watching this video. I hope it was helpful. If it was, I'll be happy if you subscribed to this channel, and see you next time. Bye.